Hi, so welcome to video 2 for geometry, and today we'll be looking at 1.5 to 1.7. So let's get into it. First, let's look at 1.5, describe angle pair relationships. So first, let's look at some key terms. Here, you can see two angles are complementary angles if the sum of their angles is 90 degrees. This is pretty straightforward, right? For example, maybe 50 and 35 are complementary angles because, like for example, 40 and 50 are complementary angles because they add up to 90. 50, 30 would be a bad example because it would be equal to 80, my bad. And what two angles are supplementary angles if the sum of their measures is 180 degrees. So maybe an example can be 100 plus 80, which would be a supplementary pair of supplementary angles because they add up to 180. So, and complementary angles and supplementary angles can be adjacent angles or non-adjacent angles as well. And basically, adjacent angles are two angles that share a common vertex inside, but no common interior points. So if they're adjacent, they would be like connected, like something like this and this. Maybe this is like 100 and here's like an 80, for example. But complementary is like one, maybe this is just 100 and another angle is 80 degrees would be what's not adjacent angles are, and non-adjacent angles, non-adjacent supplementary angles are, and this would be what I showed you here would be a pair of supplementary adjacent angles, right? I think that's pretty straightforward, right? If you're trying to find a pair of complementary angles and supplementary angles, you just have to look at what they add up to at the end. I think you can do these examples on your own. So let's look at another pair. So vertical and linear pair, right? This is very important because this comes a lot later on when you need to prove, like you'll be using like the definition of linear pair, for example, or the vertical angles congruence theorem, which you'll learn in the second chapter, coming a lot in proofs later on. So these are very important concepts and definitions you must know. But first, if you look at a linear pair, basically two adjacent angles are linear pair if their non-common sides are opposite rays. Right? What does this mean? A linear pair is something that looks like this. So the fact that there's they're opposite rays, right? Opposite. These arrows are going to opposite sides, and they're also a linear pair if they're supplementary angles. So here we can see that this is clearly 180 degrees because it's like 5, right? So we can assume maybe this is like I don't know, 70, and this is 110, which would be a pair of a linear pair. Vertical angles if there are two sides form two pairs of opposite rays. So basically the easy way to think of it is when you see like something like this, when they go opposite. So this would be a vertical angle, and this would also be a vertical angle. So basically just looking at opposites here, 4 and 5 are a pair of vertical angles, 3 and 6 are a pair of vertical angles. So they're just looking at each other, like this way is the main idea for vertical angles. Before we move on, let's just quickly look at example 4, identify angle pairs. So identify all of the linear pairs and all of the vertical angles in the figure at the right. First, let's look at some linear pairs. So if you remember that linear pairs must add up to 180, and then we can first see that, look, if we look here, we can see that 1 and 4 is a linear pair because here them two add up to become a linear pair, but another linear pair is also 4 and 5 because they also lead to a linear pair. But if you also look about it this way, something like 2 plus 3 and 5 would seem like they're a linear pair, but they're not because it's not two angles, but it's more than two angles. So in this case, only these two answers would work. But what are some vertical angles, right? So as I told you, you have to look directly at like one another. But here, like 3 and 1 is not, 2 and 5 is not. And although 2 and 4 might look like they are, like their angle value is totally different, and they're not actually totally vertical. So in this case, only 1 and 5 would work and would be vertical angles. So here's like a clear summary of what I just like told you, right? So basically, let's quickly look at this. So there's some things like you can tell from looking at this, right? So we can see that all points here are on the same plane or are coplanar as we learned in the previous sections. And we can also know that A, B, C are collinear because they're on the same line. Same with D and B and B and E. And we can also see that AC and BD and BE as well intersect at the point B. And we can also see that DBE, which would be DBE this angle, and EBC and these angles are DBE are adjacent angles, and we can also see that ABC is a straight angle, right? And we can also see point E is lies in the interior of DBC, so it's like in here, right? But you can't conclude like congruence because you don't know the exact angle measures, for example, from this diagram, because there are no angle measures given besides the fact that this is a linear pair and this is probably 90 degrees, but we don't know the value of these. Yep. And before we move on, let's just quickly look at number 7. So here's this name a pair of complementary angles and a pair of supplementary angles. So as we know, complementary angles add up to 90 and supplementary angles add up to 180, right? So basically a pair of complementary angles has to be 90. So I think something like angle JLH and angle JLG would be a pair of complementary angles, because since here's 90 degrees, you can also imply this must be 90 degrees because it's a linear pair, which means that the total is 180 degrees. So we can assume that these two angles will add up to 90 degrees, which is the definition of a complementary pair of angles, right? And let's look at a supplementary pair. I think this would be like JLK and JLG because they're two angles that will add up to 180 degrees. In this case, it is highly possible that both angles are 90 degrees, but at the end they still end up to 180, so that would be the answer for number 7. Let's look at some quick algebra. So here we're trying to look at 17, the value of M, measure angle DEG, and measure angle GEF. So DEG, GF. So from here, we know this is linear pair, which means the total number of degrees is 180 degrees. So if you want to solve this, 22 put x, let's use pencil, 22x. So because you guys know how to solve equation, you can add these, right? 22x minus 4 would be equal to 180 degrees. So if you solve this, I think we can tell that 184 divided by 22 is, from here, let's take a look at this together. So first, because we know that the total number of angles is 180 degrees, we have to add them, right? I think just showing the steps would look better. So here, let's try this. 18 plus 4 is 22, and 13 minus 9 would be 4. And here's 180, 22x, and then if we subtract 4 from 180, it's 176, not 184, don't make the mistake. 176 divided by 22 would give you a value of x is equal to 8. But remember, that's not the measure of the angle. You have to now substitute 8 back into the equation like this. In the case of here, we can probably see that the answer is 54. And that being said, the measure of the other angle would be 135 because they add up to a total of 180 degrees. Yeah. I think the other ones you can probably manage on your own. So now let's move on to section 1.6 on classifying polygons. Basically, first you have to know what polygons are, right? So let's look at this key concept here, identifying polygons. So in geometry, basically, a figure that lies in a plane is called a plane figure. Basically, they're on a plane. So anything like a triangle, a circle, a rectangle would all be a plane figure. And a polygon is a closed plane figure with the following properties. By closed plane, this is pretty clear that it's convex. This is not a good example, but something like this would not be a polygon. So it's first formed by 3 or more segments called sides. Example, the smallest sided polygon being a triangle. And each side intersects exactly 2 sides, one at each endpoint, so that no 2 sides with a common endpoint are collinear. So this is pretty straightforward. Like they have to intersect at 2 sides, maybe like this, or maybe if you look at a rectangle, something like this, right? And each endpoint of a side is the vertex of the polygon. And the plural vertex is vertices, so something like vertex, 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 which is all vertices. So what is a main property of a polygon? So they're convex if no line that contains a side of the polygon contains a point in the interior of the polygon. The polygon that is not convex is called non-convex or concave. Basically, a convex polygon is something like even if you cross lines in the polygon like this, then there's still like no point inside the polygon, right? And a concave would be a figure like this, where if you cross a line, there will be a point inside, and this would not be like, this would be the difference between concave and convex. I think most figures you will see will be convex, something like a some even looking at like a trapezoid and so on and so forth. Right? So here's some like major polygons that you will see quite a lot throughout just not just geometry but math in general. Triangle, also the foundation of trig, has 3 sides, and you guys know this is a triangle. Quadrilateral has 4 sides, like a square. Pentagon has 5 sides, so you know like the famous pentagon in the USA, that's a pentagon. And hexagon 6, heptagon 7 sides, octagon 8 sides, nonagon 9 sides, decagon 10 sides, dodecagon 12 sides, and n-gon. So by n-gon, it's just referring to polygons with any more than 12 sides. So maybe a 13-gon would be showing a polygon with 13 sides. Yeah, so in an equilateral polygon, all sides are congruent. This is pretty straightforward. This is a regular pentagon. That means both the sides, as seen here, and is also equal angular because the angle measures are also the same. So any figure, or in this case, polygon that has the same measure for all angles and sides is called regular. And if it's a polygon with only all equal sides, it's equilateral. And if it's a polygon with only equal angles, then it would be equiangular, right? I think, yeah, you can probably deal with these. So let's just kind of look at classifying the polygon by the number of sides. Let's look at 12, right? So as I told you, equilateral is when all sides are equal, and this I think rhombus has all equals. So we can tell this is an equilateral. In this case, quadrilateral, right? It is, however, not equiangular, because if you look at these 2 angles are equal, but these 2 are different, as we can see in the notation. So this is not equiangular. Because this figure is not equiangular, it's also not regular, because it's not a figure with all sides and angles being equal. So this is basically the idea here. So let's look at number 29. Each figure is a regular polygon. Expressions are given for 2 side lengths. So find the value of x. Because we know that each figure is regular, that means we can know that these sides are equal, right? Not just these sides, but every side here. So x squared plus 3x would be equal to x squared plus x plus 2. Here, because we move x to the other side, the x squared roots would cancel out, and as move 2x would be equal to 2. X would be the 1, and if you're finding the value of x, x would be 1. If you want to check your answer, 1 plus 3, let's look, 1 plus 1 plus 2, 4, it is also equal to 4, so we can know that our answer is correct here. Okay, now lastly, let's move into finding the perimeter, area, and circumference. So basically, these are some important formulas to just like kind of know when you're basically just dealing with polygons. But quickly, we call that perimeter is the distance between like around the figure, and circumference is distance around a circle, and it's only applicable for a circle. And area is the amount of surface covered by the figure. So we can see like some clear examples here, right? Square, P or perimeter equals to 4s. That means if the value of one side was 2, 2, 2, 2, you'll be doing 4 times 2, which is the 8. And 8 will be the perimeter for the square. For s squared, let's use, again, if the s was 2 again, the area would be 2 squared, which would be 4, and 4 would be your area. Rectangle, 2l plus 2w, so 2 lengths, 2w would be, let's say, I don't know, let's call here 2, 2, and 4, 4. Then 2 times 2 plus 2 times 4 would be 12, and that would be the perimeter. And your area here would be 2 times 4, which would be 8, right? And triangles, basically the perimeter is a plus b plus c. So if here's 2 plus 4 plus 5, then it would be 2 plus 4 plus 5, which would be 11 as your perimeter. For your area, because you're looking at b and h, would be 5, and let's call this like 3, then it would be 15 times 1/2, so that'll be 15 and a half as your area. Just looking at circles, so the diameter is just basically from here to here, right? And radius would be kind of half of the diameter, which would be like, or just kind of how the arc here as well. And basically you calculate the circumference or area by just using this. Instead of, I would say that you should not use this and just use 2 pi r for circumference, and remember for area, pi r squared. And that's for circles. I think you can actually do most of the questions here. So let's look at some questions here. Like let's look at number 8, for example. To find a perimeter and area of the shaded figure. So first, let's look at the perimeter, right? As remember, it's P is A plus B plus C, and A is half BH, right? So first, let's look at the perimeter. Let's look at this triangle here. A, B, C would be the sides. But because these two sides are equilateral, then here is also 15. So if you do 15 plus 15 plus 24, then it would be the answer 54, and that would be your perimeter. Let's look at area. Base times height, right? So if you look, as we can recall, let's just look at here quickly for your memory. Base is just the bottom length here. Oops, yeah, bottom length here. So if you go back here, then you would remember that the base is not here or here, but in fact, the bottom length 24. So it would be 24 times the height of 9 times 1 over half. So that would be 12 times 9, which would be 108 as your area. Yeah, that's basically the idea here. Yeah. I think converting units, if you just know the conversion for units, like for example, 12 inches in a feet, this would be doable. So let's look at here. You're trying to find 24 feet squared into inches, then that would just be 24 times 12. So if you do the calculation, you would get 288 as your answer for 25, for example. But let's lastly look at a bit challenging questions. So let's look at just 29. So it says use the information about the figure to find the indicated measure. So we know that the perimeter is 25 inches, and you're trying to find the width of W. So what's the about perimeter for rectangles? It was 2L plus 2W, right? But because we know that the length is 8, we know that 2L, or in this case, rather, L would be 8, plus 2W gave 25. 2 times 8 is 16, and plus 2W is 25. So 2W, and if you do the equation, we get W as 9 over 2, or 4.5. So we can know that W is actually 4.5. To verify this, we can do 4.5 times 2, which is 9, plus 8 times 2, which is 16, which gives 25. So we can know that width W would be 4.5 by just basically putting in values and doing kind of the equation for finding perimeter backwards. So that's how number 29 would work. And that's it. So great job finishing chapter 1. It was really fast. And if you have any questions, please feel free to reach out. And I think you guys did really, really well so far. And with the introduction to geometry. And next, you will be moving to chapter 2, where you first approach proofs. And here you look at forms of reasoning, and you'll look at the theorem I talked about earlier, the vertical angles congruence theorem. So great job, guys, and see you next time. Bye!